So we want to continue discussing linear relations, and in this particular video, we want to talk about graphing them, and then using that graph to either interpolate or extrapolate. So that means you're either going to look at the graph and read it from the graph, from the table of values that you have somewhere in between the values that you already have. That's interpolation. And extrapolation is you're going to say, if this pattern continued, either in the positive direction or the negative direction, what would happen, all right? So we want to try to graph these. If we look at this one, y equals x, then I'll just do this in the same color. So that's just going to be -2, 0, and 2, okay? And if I graph that, -2 and -2 is right here, 0 and 0 is right here, and then 2 and 2 is right here, okay? So I'm just going to connect those with a line. So you can kind of see, and again, I'm using graph paper. You should too if you're trying to graph lines, just to make sure that you're doing it accurately. And also, I'm cheating a little bit because I'm using the graph or the line mechanism here. I'm not actually drawing a line myself. Okay, I'm using the built-in one on the computer, but you can use a ruler and you should be able to get the same sort of result. So there's my y equals x. Okay, then y equals 3x. We'll do that in blue. All you're going to do is multiply each of these by 3, right? So we're going to get -6, 0, and 6, because 3 times 2 is 6. So that's going to give me -2 is going to be down here at -6. At 0, it's still at 0. And then at 2, it's way up here at 6. And again, I'm going to try to draw a line through those as fairly steep, and then I'll adjust it. Actually, that's pretty good. But then I'll go down and change it to blue so it matches our color. And I'll put, you always, when you're graphing, should put arrows on the end to indicate that this line continues. Okay, so there's my second line. And then the green one is -2x. So all these things are going to get multiplied by -2. So I'm going to get -2 times -2 is 4. 0 times -2 is 0. And then 2 times -2 is -4. So at -2, I'm going to be up at 4 here. At 0, I'm at 0 again. And then at 2, I'm down here at -4. So I'll draw a line through those. Okay, and again, I'm going to adjust it and change the color. But if you look at these graphs, the question is, what do we notice about this? And hopefully what you notice is that they are all the same in terms of they all go through 0, 0. Okay, try to get the right green color, that works. And what is happening with them is actually with y equals x, it's a fairly flat line, okay, sort of a nice flat line. With the blue one, y equals 3x, all that happened is it goes really, really steep, right? So that the change is just in the steepness of the graph. And then the green one, what you notice, hopefully, is that when it changed to a negative number that we multiplied by, it actually flipped it so that instead of it going up to the right like these ones do, it's actually going down to the right, okay? So this idea that they're all slanted, they're all oblique lines, all right? If you go back up here, oblique, vertical, and horizontal lines, these are oblique lines. But what you'll notice, hopefully, is that this number affects the steepness of the graph, okay? This number in front of the x, that's what it affects. It affects how steep the graph is, and if it's negative, it affects the direction in which it goes. So instead of going up to the right, it's going down to the right, okay? Now, what about if we look at these lines? Okay, so if I look at these lines, these are already graphed for us. We have x equals 2. So it doesn't matter what y value you pick, okay? X is always 2, or x is always -3, or x is always 4. And what happens with these lines is these become what are called vertical lines. They're straight up and down. And they're straight up and down at the x value. So x equals 2 right here, right, at 2. X equals minus 3, it's at minus 3. X equals 4, it's at 4, okay? So the difference, what we're trying to get you to sort of recognize is the difference in the equations are this. In these equations, which we said are slanted or oblique lines, there is both a y and an x. Both are included. And because both are included, you get a slanted line, and then that number that's in front of the x affects how steep the line is. Okay, so we sort of talked about what are the properties. With these, you'll notice there is no y in the equation. It's just x equals x equals x equals. So when that happens, you have a vertical line. In these equations, if you look at these equations, you'll notice that these are already graphed for you, so you can kind of pair them up. But you'll notice in these lines, what's different is there's no x in the equation. It's just y. Okay, it's y equals 4. It's 2y equals 6, which you can solve and say then y equals 3. Or it's y plus 2, which again, if you solve for y, becomes y equals minus 2. And we talked about how to solve linear equations in previous chapters of the textbook. But if you look at these, they are all horizontal lines. They're all flat like this. Okay, they're all flat. So what you end up with is if it's x and y, if y and x are both involved in the equation, you have an oblique line. It's slanted. Okay? If it's just x, then they're vertical. Okay? Straight up and down. And if it's just y, then they're horizontal. They're flat. Okay? So the graph of the equation x equals a, okay, where a is a constant, is a vertical line. So it doesn't matter, again, if you have x equals 3, it doesn't matter what the y value is. Okay, the graph of x equals 3 or x equals a, we're saying a as any number you want to pick, but they're always vertical. That's kind of the summary statement of what we just said. And what ends up happening is it doesn't matter, again, what y is, okay, because x is the only variable. And it's not really a variable when we say x is equal to 3. So it doesn't matter what y is, it's always at 3. Okay, so that's the vertical line. That's really important. If only variable in the equation is x, we're talking a vertical line. If the only equation, this again is just a summary statement. Okay, well, I already said it, but it's just kind of a summary statement for you to write down if you're following along or to look in your notes. But if it's just y equals, if there's no x involved anywhere, then it's a horizontal line. So if you look at y equals 1, then every point in the graph has a y coordinate of 1. It doesn't matter what the x value is. Okay. So again, if the only variable in the equation is y, it's horizontal. Okay. And then it's really a matter of just sketching where x is or where y is. So if we're just talking about a vertical line or a horizontal line, it's a little bit easier to draw. So in this equation, for example, x equals 5, all we have to do is go to x equals 5, which is right here, okay, and then we just sort of plot a line along there. So I can draw that pretty easily. I just draw a straight line at x equals 5, okay? If I look at this one's not exactly x equals something right now, right? But it can be because there's no y in the equation. So we solve this, we get 4x is equal to minus 2, right? If we subtract 2 from both sides. And then if we divide by 4, then we get x is equal to minus 1/2, okay? In this instance, we go to x equals minus 1/2, which is kind of right here. And then we drag it down, and I'm going to just change the color again to red so it matches what we did in terms of our line. Okay, in both cases, when we says describe the graph, they're vertical lines. And they're vertical lines at x equals 5 for the first one, and for the second one at x equals minus 1/2. But again, because there's no y, we know that it's a vertical line. Okay, so very important to recognize that. Now, if we look at these ones, same idea, but it's y equals now. So whenever we see y equals, we said it's horizontal. So we should recognize that y equals minus 4 is going to be at y equals minus 4. It's just going to be a horizontal line at y equals minus 4. This guy's a little bit different again. It's 2y equals 6, so we have to divide by 2, okay, to solve it for y. We have to get y equals. In this case, it's y equals 3. then we can draw the graph. So here's y equals 3. And if I then just go to my properties and change it to blue, you can sort of see it matches that. But again, in describing the graph, we're saying now we're at a horizontal line. That's how we say it. It's horizontal, and it's horizontal at y equals -4, and then at y equals 3. Okay? So pretty simple with horizontal vertical lines, and fairly easy to recognize. Okay? However, if there's both x and y, then we have an oblique line. We said that it's a slanted line. And to draw it, it's probably the best case scenario is just to do a table of values to sort of see what the relationship is. So what we do is we pick some x values, okay? -2, 0, and 2, and then we try to find out what y is. So if I take -2 plus 2y is equal to 6, okay, if we say x is -2, let's start there. Then that means I'm going to add 2 to both sides, so I get 2y is equal to 8. Okay, if I just go +2 and +2. Sorry, not +8, it's 2y equals 8. Let me just fix that. And then that means if 2y is equal to 8, then we just divide by 2. So we go 2y divided by 2 and 8 divided by 2, and that gives us y is equal to 4. Okay, so we fill that in there. Then we say, what happens when x is 0? When x is 0, I get 0 plus 2y is equal to 6, which means that 2y is 6, and we just divide by 2 and get y to be 3. So we put 3 here. And then finally, we let x be 2. So we get 2 plus 2y is equal to 6. So we subtract 2 from both sides, and we get 2y then is equal to 4. 6 minus 2. Divide those by 2, and we end up with y is equal to 2. Okay, and then what you would do to plot the graph, or to graph the equation, is we plot those points. So at -2, we are at 4. Okay, at 0, we're at 3. So we're here. And then at 2, we're at 2, which is here. And then we draw a line. And again, be careful with this. Use a ruler, okay, or use a graphing program, I guess, if you have one available to you. And that will make it look a lot nicer. You want to make sure it's as accurate as possible. And then we're just going to put arrows on the end again, just to make sure that we're indicating this does continue. It's not like it stopped. Okay, so it's an oblique line. So here's sort of a recap. And again, I've said this a number of times, so I'm not going to go through this again. But x and y, x and then y, all right? So you can sort of take that as a summary statement of all that we've talked about. So there's some practice here for you to go through in your textbook. Bunch of questions to try. What I would suggest is if you look at just this first question, it says which equation describes each graph. So x equals -2. So here's x equals -2, okay? And then it's a vertical line. We know it's vertical because it's just x, so we say it's A, all right? So 1 matches with A. That's kind of the idea there. This says, does each equation describe a vertical line, a horizontal line, or an oblique line? So this one's horizontal. We'll just use H. And the reason I know it's horizontal is because it's only Y, right? This has X and Y, so it's oblique. We'll use an O. This has just X, so it's a vertical line. We'll use V, okay? This has just X again, so it's vertical. This has just Y, all right? So it's horizontal. And this has both, so it's oblique. That's the idea, okay? And then when it says describe the graph, if you look at y equals 5, that's a horizontal line at y equals 5. This is a vertical line at x equals -5. Okay, so that's kind of the first part of it. And then the second part of this is going to say write an equation to describe this graph. So you have to know if it's horizontal, it's y equals, and then you have to look at where does y equal. And in this case, it's at 2. Okay. Vertical line, it's x equals, and again, you're looking just at the x value, and it's 1 here, so it's x equals 1, all right? And then again, you can go through the rest of these. I think they're fairly obvious, and then the answers are also included, okay, for all of them. So I'll leave those for you to do, but that's the concept of an oblique, vertical, and horizontal line. And again, I'll just leave you here with this summary statement because that's really what is most important.